Number 1, calculate the cosine of 480 degrees and the sine of 480 degrees. Identify the quadrant of the terminal ray and the reference angle. So, as always, we want to draw a unit circle. So, there are my axes, and there is my unit circle. An angle of 480 degrees is clearly more than one rotation around the circle. So let's take away 360 so that it becomes a smaller angle so we can see what it's coterminal with. 120. So if I spin around 480 degrees, I'm really ending up with an angle that lies in the same place as 120 degrees. So the cosine of 480 is really the cosine of 120 because they land on the same place on the unit circle, and similarly for sine. What quadrant am I in? I'm in quadrant 2, which I know is minus plus. In quadrant 2, my x values are negative, or my cosine values are negative, and my sine values are positive. What's my reference angle? Well, remember, we always drop our perpendicular back down to the x-axis. So we say, what's the angle of that triangle? Well, I spun around 120. I need to keep going another 60 to get to the 180. So my reference angle is 60 degrees. My reference angle is 60 degrees, so cosine is negative. I want negative cosine of 60. Well, what's the negative cosine of 60? If you look at your special right triangle, you would see that that would be negative 1/2. And now let's deal with the sine. The sine of 480, well, we said that 480 degrees was really the same as, the cosine was really the same as 120 degrees. Because if I spin around the circle once, I land in the same place as I would if I spun around only 120 degrees. Sine is positive in the second quadrant, so I don't need to worry about that. My reference angle is 60. So what's the sine of 60? The sine of 60 is radical 3 over 2. So the sine of 480 is the same as the sine of 60, which is radical 3 over 2. We identified the quadrant, it's in quadrant 2, and the reference angle, our reference angle was 60 degrees. It's so important that we know the basics of the unit circle, of what quadrant we land in and how that quadrant determines the sine, whether it's positive or negative, of the cosine of the angle or the sine of the angle. Number 2, fill in the chart. Write in the measure of the reference angle and the values of the sine and cosine function for the indicated values of theta. So you're definitely going to need some kind of scrap paper here to draw your unit circles and do all of that good stuff. But if I have 690 as my angle, what's coterminal with 690? Well, if I take away 360 from that, I get the same angle as 330 degrees. So 690 is really the same as 330. It's just one more spin around the circle. Well, 330 lies in quadrant 4. And what reference angle is that? Well, if I spun around to 330, I always drop back down to the x-axis to make my triangle. That little blue angle there, well, the red is 330. To keep spinning, would need another 30 degrees. In quadrant 4, cosine is positive and sine is negative. So what's the cosine of 30? The cosine of 30 is radical 3 over 2. And the sine of 30 is 1/2. But because I'm in quadrant 4, my answer is negative 1/2. That's the process we need to go through for all of these given angles. 1560. Clearly that number is bigger than 360 degrees. So let's figure out what it's coterminal with. I'm going to just keep subtracting 360 from it until I get an angle that is between 0 and 360. So 1560 minus 360, minus 360, minus 360, so close, minus 360, 120 degrees. This angle is coterminal with 120 degrees. 120 degrees lies in quadrant 2. What reference angle do we get? So I land in quadrant 2. I spun 120. How much more do I need to get to the x-axis? I spun 120. I need another 60 more to get to 180. In quadrant 2, cosine is negative and sine is positive. My x values are negative. My y values are positive. The cosine of 60 is a half, but it's going to be negative. The sine of 60 is radical 3 over 2, and it's going to stay positive. 855 degrees. I have no idea what angle that is coterminal with, but I'm just going to keep subtracting 360. And after I subtracted 360 twice, I ended up with 135 degrees. So 135 degrees lies on the same ray as 855 degrees. 135 is clearly bigger than 90, but less than 180, so we're in quadrant 2 again. I'm in quadrant 2. I spun 135. How much more do I have to keep spinning? Remember, your reference angle always goes back to the x-axis. I spun 135. I need to spin another 45 to get to 180. So that blue angle there, my reference angle is 45. We're in quadrant 2 again. So remember, your x values are negative, your y values are positive. The cosine of 45, well, I like the sine and cosine of 45 because they're the same, except this time cosine's negative, sine is positive. Negative 330. There's a couple ways you can do this. You can say, I know how a negative angle measure works. I just need to spin clockwise from the positive x-axis 330. So I end up in quadrant 1. If I spun backwards 330, I'm left with another 30 degrees. So I end up in quadrant 1, and my reference angle is 30 degrees. Another way to go about this is say, what's coterminal with negative 330? Well, if I add 360 to that, you end up with 30 degrees again. But remember, negative angle measures go clockwise. They start spinning into the fourth, then the third, second, then the first. They go the opposite direction from the positive x-axis. Since I'm in quadrant 1, both trig functions are positive. In quadrant 1, my x's are positive and my y's are positive. What is the cosine of 30? That's the first column, right? The cosine of 30 is a radical 3 over 2. The sine of 30 is 1/2. Negative 510. Negative 510, I'm just going to keep adding 360 to make that a positive angle measure. Negative 115, I could go from there, but if I add another 360, I'm coterminal with 210 degrees. And 210 lies in quadrant 3. If I spun 210 degrees, my reference angle is always with the x-axis. I spun 180. How much more do I have to keep going? Another 30. So it's the same answers as up above, but in quadrant 3, my x's are negative and my y's are negative. Cosine's negative and sine is negative. So negative radical 3 over 2, negative 1/2. And finally, negative 135. I'll do it two ways. You could draw your picture saying I'm going to go backwards negative 135, go negative 135 and land in quadrant 3. Or you could say I'm going to find what's coterminal with that. If I add 360 to negative 135, it's coterminal with 225, which again is that same angle in quadrant 3. We're in quadrant 3, so both sine and cosine are negative. Cosine and sine are negative, that's the order here, because cosine are my x, negative y. What reference angle do I have? Well, I always go back down to the x-axis to make my triangle. And there's a couple ways to look at this. I spun negative 135, I'm going to keep going, so I need another 45 degrees. Or you could say I spun a positive 225. How far extra did I go there? I went an extra 45 degrees there. Cosine of 45 is radical 2 over 2, but it's negative. Sine of 45 is radical 2 over 2, and it's also negative because we're in quadrant 3. Hopefully filling in this table has helped you organize your thoughts of how do I find the cosine and the sine of these special angles. If they're larger than 360 or less than 0, we figure out what's coterminal with them, so you add or subtract 360 because that's just another spin around the circle. The quadrant tells you who's positive and who's negative. You make your reference angle always with the x-axis. We always go to the x-axis for our reference angle. And then you just need to use your special right triangles to figure out, is it 1/2, radical 3 over 2, radical 2 over 2. Number 3, determine the following values of the expressions. Make sure you had a unit circle. I'm going to draw a unit circle down here, just so we have our unit circle readily available. This question may seem like a lot, but it's not terrible once you have that unit circle out. I notice that all of these are 90, 360, 180. These are on the axes. All of these angle measures fall on the axes. There's 0, 90 degrees, 180, 270. It's also 360. But what point is that? That's the point 1, 0. It's just knowing our basic, what point is that on the coordinate plane. This is the point 0x, 1 for y. That is negative 1, 0. And this is 0, negative 1. And it's essential to our whole understanding of trigonometry that any point on the unit circle, x comma y, is the cosine of theta. Cosine is our x value. Sine theta is our y value. So when I say what's the cosine of 90, well, cosine is the x value at 90. It's equal to 0. What's the sine of 90? 1, because that's the y value at 90 degrees. Cosine of 360 is 1, because that's the y value. That's the x value. Sine of 360 is the y value. 0. Sine of 180. Sine is y, so 0. Cosine of 180, that's our x, negative 1. Sine of 270, that's our y value, negative 1. And the cosine of 270, well, cosines are x value is 0. The sine of 450. Well, 450 means I have to spin around the circle more than once. So what's coterminal with 450? Let's subtract 360 from that. Gives me 90 degrees. So what's the sine of 90? The sine of 90 is 1. So the sine of 450 is also 1. The cosine of 0, cosine is x. Cosine of 0 is 1. Sine of negative 90. There's a couple ways to think about this. I can spin backwards 90 degrees. Sine is y, so that's negative 1. So I spun backwards 90 degrees. Spun clockwise 90. Or you could say, well, what's coterminal with 90? Let's add 360. That's the same as 270. Still negative 1. The cosine of negative 270, well, let's spin backwards negative 270 degrees. The cosine of negative 270 is 0, because that's my x value there. If I added 360 to that to figure out what's coterminal with it, I would have gotten 90 degrees, and the cosine of 90 is 0. So this may have seemed like a lot, but it's really just picking off the coordinates, the x-coordinate or the y-coordinate, from those nice points, those nice integer value points on the unit circle. 4. Jane says that since the reference angle for rotation through negative 765 degrees has measure 45, then the cosine of negative 765 degrees equals the cosine of 45, and the sine of negative 765 degrees is the sine of 45. Explain why she is or is not correct. Well, I have no idea what negative 765 degrees is. I could sketch that, but that'd be an obnoxious sketch to make. So let's add 360 to see what's coterminal with it. If I add 360 and get negative 405, I still have no idea. I'm going to add another 360 and get negative 45. Maybe you could work with that, but I like working with positive angle measures. I get 315. So from one of these two, you could have at least made the sketch. You could have at least made this sketch on the unit circle that A, you had to spin negative 45 degrees, or you had to spin 315 degrees. Your choice there. Our reference angle always drops down to the x-axis. What's that blue angle there? That blue angle is actually 45 degrees. So she is correct in saying that. However, in quadrant 4, my x's are positive and my y's are negative. So cosine is positive and sine is negative. So Jane is explain means you need a sentence. You need to say something along the lines of Jane is correct when she says the cosine of negative 765 degrees is equal to the cosine of 45 degrees. That is correct. That's good. However, this statement is not true. The sine of negative 765 degrees is equal to the negative sine of 45 because we're in quadrant 4, and in quadrant 4 our y values are negative because sine is the vertical distance on our unit circle. So write a sentence saying she's correct there, but she's incorrect here because sine is negative in quadrant 4. And finally, number 5, let P be the point 2, 3, and theta be the angle formed by the x-axis and the ray from the origin through P. Let's get a picture before we even go on. I have a point P, 2, 3. There's P. Ryan claims that point is 2, 3. Our friend Ryan claims that the cosine of theta is 2, because that's the x-coordinate, and the sine of theta is 3, because that's the y-coordinate. Explain why he's incorrect. Well, yes, we have been saying that cosine is your x value and sine is your y value. That's only when you're in the unit circle. 2, 3 is not on the unit circle. So Ryan's incorrect there because you can't just look at the x and y coordinates when you're not on the unit circle. To do a question like this, where that's your angle theta, you have to make your triangle. That's 2, that's 3. Well, what's the hypotenuse? The hypotenuse is, well, 2 squared plus 3 squared equals c squared. 4 plus 9 is c squared. So radical 13 is c. 4 plus 9 is 13, square root both sides. So when I find the cosine of theta, the cosine's not just 2, it's 2 over radical 13. When I find the sine of theta is not just 3, it's 3 over radical 13, using opposite over hypotenuse and adjacent over hypotenuse, respectively, for sine and cosine. If we were to go on the unit circle, if we knew this point was on the unit circle and we made a little miniature unit circle here, then this red point, that red point there would have the coordinates 2 over radical 13 and 3 over radical 13. Because that point is on the unit circle, that's my cosine, that's my sine. Remember, cosine is x, sine is y. So that only works. You can only pick out the x and y values when you know you're on the unit circle. When you're not on the unit circle, like point P is not on the unit circle, you have to use good old SOHCAHTOA right triangle trigonometry. So that's why Ryan is incorrect. Write a sentence saying that 2, 3 is not on the unit circle, and you should probably find out what the cosine and sine actually are. So don't fall for the mistake that Ryan made here, where he just picked out the x and y values. You actually have to use right triangle trigonometry, because 2, 3 is not on the unit circle.